For the next example of solving trig equations, we're going to be doing 3 tangent squared of theta over 2 is equal to 1. So again, this is 3 times tangent squared of theta over 2 equals 1. So we have a half angle inside. The question again is, what is theta? In other words, which angle, when I plug it in, makes this equation true on both sides? Even more specifically, what makes the left equal to 1 if the right is equal to 1? And again, we want to use a domain, meaning what theta could be between. So we're going to say it's going to be between 0 and 4 pi, including the endpoints. And that's because a lot of times, without a domain, you'll have infinitely many solutions for theta. And we want to limit it to a certain domain. So we're going to do the same steps as we did for the last example. If you haven't watched that yet, watch example 1. Step 1 says to move all the trig functions to the same side. Well, guess what? Tangent's already on one side, 1 is on the other, which is not a trig function, so we're good to go for that step. Step 2, write all the trig functions in terms of the same angle. Now, it's going to be preferably a single angle, but if you already have one trig function in the equation, you don't need to write it in terms of one single angle. So this theta over 2 is going to be completely fine because we just have a tangent in the equation. Step 3, if possible, convert all the trig functions into the same function. Well, guess what? They're all tangent. So step 3 is also already done. So we can see we're starting to see that this is actually a pretty simple equation to solve. Step 4, replace the trig function with a variable. So I'm going to say, now students get confused by this, but if you only have one trig function, then just include whatever's in the parentheses. So in this case, it's theta over 2. So we're going to say that tangent of theta over 2 is equal to x, and that way, whenever there's a tangent of theta over 2, we can replace it with x. So in this case, the tangent squared of theta over 2 just becomes x squared. We bring the 3 down and the 1, and now we can see this is a very simple algebraic equation we could solve. Divide by 3 and take the square root. So 3x squared equals 1 is a very simple equation to solve. Step 5 is to solve for the variable. So divide by 3, x squared equals 1/3, take the square root. Don't forget the plus or minus when you take the square root. So you get x is equal to plus or minus the square root of 1/3. And then you need to rationalize the denominator and do all that. I'm going to spend forever explaining that. You guys have done that enough. X is equal to square root of 3 over 3, or x is equal to negative square root of 3 over 3. Remember, when you take the square root, do not forget plus or minus. I'm going to draw an arrow here at the plus or minus. Hopefully that'll help you remember that. Okay, step 5. Again, these are the same steps we're going to do every time to solve a trig equation. Same algorithm. Replace the variable with the trig function. So remember how we said x was tangent of theta over 2? In step 4, well, we're going to replace x with tangent of theta over 2. So now we have 2 separate trig equations, which I will divide with a dotted line. And we need to solve both of them so we can figure out what theta is equal to. Okay, so we're going to do the same steps we did before. Step 7, take the inverse trig function of both sides. So I'm going to take tan inverse of the left and tan inverse on the right. And I'm going to do that to both of my equations. Remember, when you take the inverse function of a normal function, it cancels out and you're left with what's just on the inside. In this case, theta over 2. The reason we're doing that is because we're trying to get theta by itself, and we cannot get it by itself if we can't cancel the tangent. And the only way to cancel the tangent is to take tan inverse. So we're going to do that on both sides. So we're left on the left with theta over 2 is equal to tan inverse of square root of 3 over 2. And on the right, theta over 2 is equal to tan inverse of negative square root of 3 over 3. Can anybody guess what the last step is? How are we going to get theta by itself on either side? Well, if you said multiply by 2 on both sides, you are correct. So that's being divided by 2, so I have to multiply it on both sides, which is exactly what I'm going to do. Now, before I do that, for step 8, solve for the angle, we can actually go ahead and replace each of these expressions with what it's equal. So, for example, tan inverse of square root of 3 over 3. Where does that occur from 0 to 4 pi? Remember, the original domain was from 0 to 4 pi. Where does tangent equal square root of 3 over 3 on the unit circle? Now, because it's 0 to 4 pi, we're actually talking about 2 complete revolutions, right? So it's going to be double the amount of angles as we normally would from 0 to 2 pi. for one example, we know it's going to be square root of 3 over 3 at pi over 6, right? And where else is it positive? It's positive in the third quadrant at 7 pi over 6. Okay, so we're going to write pi over 6 and 7 pi over 6, right? And furthermore, on the right-hand side, we have tan inverse of negative square root of 3 over 3. And again, I'm going to draw another unit circle right here. We're talking about 2 full revolutions. So tangent is negative in the second and fourth quadrant, so it's going to be at 5 pi over 6 and 11 pi over 6. Okay. Now I know what you're thinking. How do you know? What about the other angles? What about 13 pi over 6? In other words, past 1 full revolution. Well, you're going to see that because you have a theta over 2 here, when you double these angles, it's going to end up making them within 0 and 4 pi. Okay? If we try to pick angles even bigger than that and double them, they will be outside of 0 to 4 pi. All right, so that is definitely important. Now you can try that. You can write 13 pi over 6, but if you double that, you're going to get 13 pi over 3, which is outside of 4 pi. Okay, so I'm sorry. So now, how do we solve for theta? Well, actually, we have 4 equations going on. I'm going to divide these so you don't get confused. So now that we've replaced the trig functions with what they're equal to, these 4, we can just multiply everything by 2, as I alluded to over here. You actually could have multiplied by 2 first, but then you would still have to find the inverse. So multiplying everything by 2, we get pi over 3 for the first answer, 7 pi over 3 for the second, 5 pi over 3 for the third, and 11 pi over 3 over 4. And as you can see, I'm just going to draw a little number line here. Every single answer that we got, whoops, put a 4 there, is in between 0 and 4 pi. If we tried to pick any number bigger than 11 pi over 3, that's going to be bigger than 4 pi. But all of our numbers are in between. Okay, had there not been a theta over 2, then we certainly could have written out more angles. Basically, instead of just figuring out the inverse of these within 0 and 2 pi, we could have chosen, for example, 13 pi over 6, and then the next one, and the next one, and those all could have worked. But because of the theta over 2, you ended up doubling that, so you can't do that. Just go from 0 to 2 pi, which is half of 4 pi. Okay? So now we're going to plug all these in and check to see if they work. I'm going to plug in pi over 3 because that's my first solution. Okay, and then I'm going to plug in 7 pi over 3, so let's plug in pi over 3. Pi over 3 over 2 is pi over 6. Tangent of pi over 6 is square root of 3 over 3. If you square it, you get 3 over 9, but then you have a 3 over here, so you end up getting 9 over 9, which is 1. And the same thing works out here, and I can already tell you that the other two work out the same. They are all solutions to the equation, because they all ultimately give you square root of 3 over 3 when you plug them in. Well, actually, the 5 pi over 3 would give you negative square root of 3 over 3, but you'd be squaring it, so it would become positive, so you'd still get 9 over 9. Same thing is true for the 11 pi over 3. So that's it for this example. These are our 4 answers. I will go ahead and circle them. Sometimes you will get 4 answers, especially when your domain is from 0 to 4 pi. If you have any other questions about this example and these 9 simple steps, let me know.